All right, good morning, good afternoon, whatever it is for you. Great day to learn about math. We got lesson 6.5, analyzing graphs. So now this one is pretty much learning how to read how a graph is presenting information to you. And this one actually does have a lot of real life application to it. Being able to read some business models, being able to read the forecast of certain maybe medical conditions, being able to understand what is happening with the graph, like stop the curve type of thing, slow the curve, as you may have heard many, many times back in March and April. So let's see what we got. Analyzing graphs. This comes directly out of the book. If you want to go ahead and preview the book, you can definitely do so, but it's not required because it's right here. So example 1, analyze graphs. The graphs show the temperatures throughout the day in two cities. Part A, describe the change in temperature in each city. So what we need to do is realize that we are talking about, again, X and Y information. So it's talking about our ordered pair. So in other words, when I read, I need to be concerned with the time first, because again, that's really our x-axis right here. Then I need to be thinking about the y-axis. So in other words, one of the ways that we can describe this graph is as the time increases. So maybe like this is, I don't know, like 1 a.m. And then here in the middle, maybe that's like 12 p.m. And then it progresses to maybe like 8 p.m. So again, those numbers are just kind of out there, nothing specific, but you'll see what I'm talking about. So essentially, the temperature, and you're going to notice as the temperature, actually, as the time increases, meaning it's morning, early morning, afternoon, evening, this would make sense, right? Because the temperature is increasing, reaches its high point, and then it's decreasing. So in other words, as the time increases, the temperature increases and then decreases. Now what about this one over here? Different city. We still have X and Y. This might not be the same type of time scenario, but regardless, it's as the time increases. So the day is changing essentially. But what's happening to the temperature? So if you notice here at the beginning, not too sure what that time is, but the temperature starts to drop, and it drops pretty quickly. Do you notice how quickly the slide would send a little kid flying down the slide? Whoa, really fast. And then right here, as the time is increasing, as the day keeps going by, right here, there's no change in the temperature. The time is changing because the time is always increasing, but the temperature gets to stay the same. So there's no change. That's a constant temperature. No change or constant. And then if you notice here, it starts increasing. So it decreases pretty quickly or rapidly. Then there's no change or constant, and then it starts to increase. So the temperature is going up, but it's not going up that quickly. If you notice, if it was like this, that'd be a really quick change. But here, it's more of a gradual increase. So it's going uphill, but gradually. And it kind of goes back to our slopes, right? Newport, Oregon, the temperature decreases, so that looks like it's going downhill. That's that negative slope. Then it stays the same, constant, and then it becomes increasing just a little bit. All right, so let's see what the book actually suggests. So for Belfast, they say the temperature increases at the beginning of the day. Yeah, we said that. It doesn't say anything about, like it reached the max. We mentioned that. Then the temperature begins to decrease. Ooh, and it says at a faster and faster rate for the rest of the day. So like it's going down pretty quickly. So it's not a straight decrease like it was over here, which is still pretty quick, but it's a curve. And the curve part, again, it's decreasing, but it's going a little bit quicker, especially as the sun starts to go down. All right, Newport, Oregon. Let's see. The temperature decreases at a constant rate. So yeah, it decreases, but it decreases quickly. So that's still constant. Then the temperature stays the same. So that's another constant. And then it increases at a constant rate. So again, the constant means it's staying the same. So it decreases constantly, stays the same, no change constantly, and then it increases constantly, which means it's not getting faster and faster, kind of like this scenario was over here. All right, let's see. Okay, we've got two different types of birds. You may be like, I don't care about birds, Mr. Marino, but that's okay because again, we're going to learn about this. So maybe you've seen pelicans. They're like a big, slow bird. Osprey, that's like a fighter. That's like a jet fighter. That's what I like to think about. So it wants you to, again, describe this. I like talking about the osprey first. Let's go here. So imagine a hunting bird. So it's way up high. And then it starts decreasing its height because that's the vertical distance, right? So as the horizontal distance increases, so it's flying and it's going across the land, its vertical distance, meaning the distance from the ground to the bird, is decreasing. And then all of a sudden right here, let's call this point B on our graph. Point B, all of a sudden the bird, the osprey, sees its target and it, whoa, look how, that's almost like straight up and down. That's decreasing rapidly, right? It's a constant rapidly, but it's rapidly. It's like it's diving to get that animal. Maybe it's a funny bunny. I don't know. Where the pelican, it's going down. Vertical distance is decreasing. Remember, the horizontal distance is always increasing, but the vertical distance is decreasing. Oh, and then it goes a little bit quicker, and then it glides in, and then it scoops up that fish, right? Like on Nemo, the pelicans want to eat the fish. Okay, so we just described the path of the bird. 3 comparisons from the graph. So, looking at these, we can say, okay, compare contrast style. The horizontal distance is increasing. The vertical distance is decreasing as well. But about that whole gradual idea, remember this is like it's decreasing and then it's decreasing kind of quickly and then it's decreasing slowly. So it's the vertical distance is still decreasing, but at the rate that it's changing, it's quite different than what you have over here on the osprey. And then if you notice, the osprey, like it attacks the animal on the ground. So the graph actually touches the x-axis, where the pelican, it just kind of swoops down. So it doesn't quite touch the ground. Because again, the vertical distance at the very bottom would be touching the ground. Silly birds. All right, let's come back to this one here. I want to actually jump right into a homework problem for you, and then we'll go back to that other one because it might help you understand a little bit better, because those other two really want us to describe the graph and make the graph. All right, let's see. Dylan rides, so this is actually the first problem of your homework. Dylan rides his motorcycle from his home to his friend's house. Okay, so this is our starting location here. How many miles did Dylan travel during his trip? Let's see. This is the time, but I want to look at the miles. And if we're going to end up here, that's like the end point to his friend's house, and I go over, yeah, I'm going to notice right there. That's 125 miles. At what time did Dylan stop to have lunch? Now remember, for the stopping, we said the time is still going to be increasing, but the temperature, or in this case, the distance, would not be changing at all. It's that constant piece, the flat location. Right here is when he stopped. So in other words, you could say he stopped after 2 hours. Now that doesn't mean that it's necessary at 2 o'clock. That's just 2 hours after he started his trip. So at what time did Dylan stop to have his lunch? You could say Dylan stopped after 2 hours. What is Dylan's speed in miles per hour during each hour of his trip? So let's see. Okay, we're going to have a multiple I think this might be connected to the slope. There we go. All right, so from 0 to 1. So 0 to 1, we're going to say m is equal to, because that's the slope again. All right, so that's 1 hour, and let's see, he drove 25 miles. So to get from part A to part B, he drove 25 miles. Now remember, it's rise over run, miles per hour. So that's 25 miles per hour, right? All right, from 1 to 2, hour 1 to hour 2. Remember, it's rise over run, so that's really going to be part C here. That's still going to be an hour. But let's see. Ooh, notice the distance that he drove. He went from 25 to 75. 25 to 75 is 50. So he drove 50 miles per hour, that one. All right. Let's see. We got 2 to 3. That's still going to be an hour. Running out of room there. And again, that's going to be part D. Oh, wait a minute. That makes sense, right? Because C to D, they were not going at all. So that's 0 over 1 or just 0, slope of 0. So 0 miles per hour. And I'm going to come down here because I'm losing some room. Maybe I can bring it over here. All right, we did 2 to 3. Now we're going to go to 3 to 4 and 4 to 5. Again, m is for the slope, not miles. All right, so from, be right there. So from 3 to 4, again, which is an hour, he went from 75 to 100, which is 25 miles, so 25 miles per hour. And then from 4 to 5, again, that's still 1 hour. He went from 100 to 125, so that's still 25 miles per hour. So most of it, he was going 25 miles per hour, but he got this nice open stretch, got to go 50 miles per hour, stop for lunch, 0 miles per hour. Oh, right there, part D. What is the fastest average speed during his trip? We just said that. So during hour 1 to 2, he went 50 miles per hour. So 50 mph. Write a story that will represent his trip. So you're just going to go ahead and put a small paragraph there. Not really a paragraph. You can say Dylan and then submit a few sentences, just a little scenario. Why was he going to his friend's house? Why was he able to pick up speed between 1 and 2? Maybe he was stuck behind someone between part A and part B, you know, a slow truck or something like that. But again, just be creative. Go ahead and submit something small. Remember, on the worksheet, you can use your Kami extension there. So now that you've seen how a graph is played out, let's go ahead and take a moment to look at these two scenarios here that we need you to go ahead and make a simple graph. So what we're going to do is we're going to start off with the idea that we're still going to go ahead and use essentially an L graph. And remember, that is definitely going to be continuing there. So we would say that this is really the X, and this again is the Y. So a stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while and then slows down at a constant rate until coming to a stop at the next station. So this is obviously going to be your time. And let's see, subway, that'll probably be miles, right? Miles per hour. Or really just your speed, if you want to call it that. So it says it's stopped. So that's going to start here. So part A starts at the corner. And it says it gains speed at a constant rate until it reaches its maximum speed. It travels at this speed for a while. And then slows down at a constant rate until coming to a stop. So it might look something like this, where it's increasing constant. So again, it's like a line. And then it says that it reaches its maximum speed. So it means the speed's not going to change at all. and then slows down at a constant rate until it comes to a stop. So part B is where it reaches its top speed. So A is starting off, part B is top speed, then it stays there, or it's, what's it say? Yeah, maximum speed. Stays there for a while, and then at part C, it realizes, or the conductor realizes, hey, I got to start slowing down at a constant rate. And then at part D, they stop, they get up to that next stop. Maybe some of you have been on a subway before. It kind of starts off a little jerky. So I don't know how they can get like a constant rate, but that's how it was written. So again, it increases, the speed stays the same, and then the speed decreases. And again, the time always increases though. So if we were to write it again, it would say as the time increases, because we always start with the x-axis. The speed increases, stays the same, decreases. All right, one more. A fully charged battery loses its charge at a constant rate until it has no charge left. You plug it in and recharge it fully. Then it loses its charge at a constant rate until it has no charge left. Excellent. This happens all the time with teenagers. Oops. All right, so I'm going to make my L graph here. Not every scenario, but almost every scenario is going to be dealing with time. And then we got the charge here. And that's probably like what on your battery percentage, battery life. All right, so actually the arrow cannot be here because you're not going to charge it above 100%. That's kind of silly. All right, so we're going to say that this right here is part A, and that's going to be 100% charge for the battery. Hopefully that makes sense. It says a fully charged battery, so that's why we're going to start there. We're going to label it as part A. Loses its charge at a constant rate until it has no charge left. So obviously it's going to be decreasing, and it's a constant rate. So I don't know how fast your device decreases. Sometimes older devices, it seems like it, sucks the battery really quickly. So we're just going to make it look constant. And then that's going to be point B. We can just label it point B. Has no charge left. Oh man, then you got to plug it in. Now, it depends on your scenario. Sometimes you don't realize or you can't charge it. But we're going to say that you're going to be one of those people who have the access and you didn't charge it before it died, but it dies. Now you're going to plug it in. So it's going to say you plug it in and recharge it fully. So we don't know exactly how quickly it's going to recharge, but again, it's a nice line. And it reaches up to that maximum 100% again, so that's part C. Then it loses its charge at a constant rate until it has no charge left. So again, you're gonna deplete it completely all the way. Sorry, those lines aren't the greatest. Down to part D. So starts off full, dead. Charge it up, dead. And that's essentially how our phones, right? Sometimes we run it all the way out, but sometimes we catch it before it dies. So that would be looking like this. This is probably a little bit more life scenario. Starts here, it decreases, but before it reaches 0, maybe you charge it up. Then you have to unplug it, and then it starts to decrease. Maybe you go a little bit more. And then maybe at nighttime you plug it in, and it gets back up to 100. And then let's say that you're doing your ticky-talkies, and whoa, it decreases to 0, and you lost all the battery. So again, that might be a little bit more specific scenario for your situation, but regardless, we're talking about the increase, the decrease, and then that special part that when it stays the same, which is right here again. The speed did not change. That's a different type of constant. So constant increase, constant staying the same, and then constant decrease there. It doesn't change when it's flat. Awesome. All right, so what you're going to do now is go ahead and work on your assignment. All right, be amazing.